thank you so much, everyone, for coming tonight. It's great to see such a full house for this important topic. I also want to say just a huge thank you to our hosts, The Dream Inn. They've been so incredible in getting this room ready for us and sponsoring this event for us, so thank you. Also, a thank you to all of our panelists for taking the time to be here this evening. I really appreciate it. And also to the Save Our Shores staff and volunteers for making this event possible and helping out tonight as well. So thank you to everyone. We are here tonight for the first of 6 speaker series events that we'll be hosting this year. And this year is really important because it is the 50th anniversary of Earth Day this April. So as such, we have decided to theme our speaker series around this topic. And we really want to highlight the importance of this pivotal year by discussing growing problems and groundbreaking solutions for our oceans and climate. So tonight we have 5 distinguished experts to help us explore topics relating to the conditions of our oceans. And we'll be discussing harmful algal blooms and red tides, and the domoic acid toxin that they can sometimes produce. We'll also identify the effects of this toxin on our ecosystems and the potential impacts of rising ocean temperatures on the occurrence and persistence of these events. We'll begin with our speaker introductions, and we'll jump right into a panel discussion. We will save time for audience questions at the end, so if you do have questions, hang on to those. We'll pass a mic around at the end. And we'll plan to end the evening at about 8 p.m. If anyone needs to use the restroom, it's out the door and to the right. And also feel free to grab drinks from the bar in the back at any point, should you like. Great. So with that, I would like to introduce our speakers. Great. So here with us this evening, we have Dr. Julia O'Hearn. Julia is the operations manager for the Marine Mammal Center's Monterey Bay Triage and Rescue Hospital. Julia grew up in Des Moines, Iowa, and earned a doctorate in oceanography from Texas A&M University. After working as a research assistant on oceanographic projects around the world, she earned her 100-ton captain's license and worked on dive and research vessels in the Gulf of Mexico before moving to Monterey Bay in 2016. She's a co-chair with the Monterey Marine Protected Area Collaborative and an active participant in the West Coast Large Whale Entanglement Response Network. When not at the Marine Mammal Center, Julia can be found operating a whale watching boat or hiking with her dog, Barnacle. Thank you for being here. Okay. Also from the Marine Mammal Center this evening, we have Adam Ratner. Adam joined the Marine Mammal Center in 2009. As the Associate Director of Conservation Education, he challenges guests and community partners to think differently about ocean conservation using the stories of individual patients that are rescued by the center. Adam was named one of the 30 under 30 game changers for the planet by the North American Association for Environmental Education, serves as the chair of the National Training Committee of the National Network for Ocean and Climate Change Interpretation, and is the executive chair of the Bay Area Climate Literacy Impact Collaborative. Thank you, Adam. Next up, we have Casey Regnier. Casey is the Director of Applied Water Science for the Monterey Bay Aquarium, where she's been for 4 years. Her team manages the water chemistry, microbiology, water treatment, life support design, water research, and discharge permitting for the aquarium. Casey holds a Master of Science in Marine Biology and Neuroscience from University of Hawaii, a graduate certificate in Natural Resource Management from Harvard University, and a Master's in Sustainability from Harvard. After starting her science journey in Hawaii, working on neuropeptides of sex-changing fish, her fascination with the physiological interactions of marine organisms with their immediate environment led her into the wider field of water science and its specific applications in conservation and industry. Thank you, Casey. Okay, our next speaker is Lisa Utall of the Monterey Bay National Marine Sanctuary. Lisa develops science-based programs and interactive exhibits that use her marine research and education background to deliver science, technology, education, and art and math experiences to a broader audience, with the goal to instill behavior change that results in ocean stewardship. She was the project manager for the facility and exhibit design, development, and construction of NOAA's Sanctuary Exploration Center. She has also created exhibits for the sanctuary that combine art, science, and technology on topics ranging from salmon, sound in the ocean, and whaling. Lisa recently created a plankton monitoring network, which is implemented by community scientists along the sanctuary's coast and focuses on long-term plankton and microplastics observations. Lisa graduated from Moss Landing Marine Laboratories and conducted midwater research on gelatinous organisms with the Monterey Bay Aquarium Research Institute. Trained in both tropical and temperate ecosystems, she's focused on invertebrate biology and the charismatic microfauna in the ocean. Lisa loves to scuba dive, has a passion for beach volleyball, and taiko drumming. Thank you, Lisa. And last but certainly not least, we have Dr. Raphael Kudela. Raphael Kudela is a professor in the Ocean Sciences Department at University of California, Santa Cruz. Dr. Kudela has conducted research on aquatic ecology with an emphasis on marine systems, but also including land-sea interface and freshwater systems for more than 2 decades. His research focuses on the factors and processes linking phytoplankton productivity to higher trophic levels, including the ecology, mitigation, and prediction of harmful algal bloom events, changes in global productivity and fisheries, and linkages to human use of aquatic systems. He earned his PhD in biology from the University of Southern California. Kudela currently serves as co-chair of the Global HAB Program, an international expert working group focused on HABs, and is a member of the Global Ocean Observing Systems Biology and Ecology Panel. He was also a lead author for the Intergovernmental Panel on Climate Change, Special Report on the Oceans and Cryosphere in a Changing Climate, released late last year. Thank you, Raphael. So now that we've introduced our speakers, we can jump right into our discussion for this evening. I wanted to first start by kind of getting everyone on the same page and just developing a baseline understanding of what these harmful algal bloom events are and what red tides are. So first we'll start by discussing the causes of harmful algal blooms and just a basic definition. Raphael, I'd like to start with you.
All right, there, I fixed it. And so tonight we're talking about both toxic algae and also red tides, and they're not necessarily the same thing. And so just to start with, when we say a red tide, it's a discoloration of the water. And so it's usually from phytoplankton. But a couple of years ago, you may remember that down in Monterey, they had green algae all over the beaches, and that was actually macroalgae. Speak up. Okay, thank you. All right. Okay. And so it could be macroalgae as well, and that's just a discoloration of the water. And a lot of the times it's completely harmless. Sometimes it's beautiful, it's bioluminescent at night. Sometimes you get pretty colors like orange or red. And then sometimes there's toxins in the water that you can't actually see, and it doesn't change the color of water at all. And so when we talk about harmful algal blooms, it's just any bloom that we don't like, that does something that's negative. And so it could be low oxygen, it could be toxins, it could be stuff accumulating on the beach that stinks. All of those would be considered harmful algal blooms. So can I have the next slide? And so here on our coast, there's several that we keep track of. The state keeps track of it, the federal government keeps track of it. And if we start at the top, there's an organism called Alexandrium catenella, which causes paralytic shellfish poisoning. And that one is really scary. We don't get it in California very often, but when you are exposed to it, it shuts down your lungs and other systems, and there's really no cure for it. And so if you remember Francis Gary Powers in the U-2 flight back in the 1960s, he actually had a poison pill that was the toxin from that algae because there's no antidote. And so, he decided not to chew it, but he did have that. Pseudonychia is the middle one on that. It looks sort of like straw or hair. And that's the one that produces domoic acid. It shut down the Dungeness crab. It causes all kinds of problems with marine mammals here in California. And that's the one we usually think of when we think of toxic algae in California. What's a little bit unusual is it's a diatom, and normally we think of diatoms as being healthy, something the fish are eating. And then finally, microcystis, which if you're familiar with it, it's pond scum basically. You think of it more in freshwater. But in the last 10 years or so, what we've been seeing is those toxins are coming out of the freshwater into the coastal ocean, and then they're being consumed by organisms like otters. And the otters are actually getting poisoned from these freshwater algae. And so those three are all what we call regulated. There's guidelines for it. There's a certain level of toxin that you're allowed to be exposed to if you're consuming fish or shellfish. And so the state keeps track of that very, very carefully. I think one thing to point out in California is we have this fantastic record of people, humans, not being poisoned because there's really good monitoring and they very closely keep track of the food that ends up in the stores. If we go to the next slide, there's also a bunch that oftentimes produce red tides, discolorations. And so Lingulidinium at the top there, that's sort of that weird-looking soccer ball thing. That one actually caused the big abalone die-off from a few years ago in Sonoma. And so it produces a toxin called yesatoxin, which is pretty mild. It doesn't really do anything to humans. You just get sort of mild food poisoning symptoms, but it's really detrimental to things like abalone. Akashuo you've probably seen. The red tides we've had over the last 4 or 5 years have mostly been that organism. And so when you get that sort of mahogany brown water and all the foam building up on the coast, that's usually Akashuo. And then Serratium is another red tide former. So if you see really bright red water, that's typically Serratium, which is a dinoflagellate. And then finally, we have, in places like San Francisco Bay, we have something called Heterosigma Akashuo. And that one's super interesting. It causes fish kills. What it does as a defense mechanism, it actually produces hydrogen peroxide. And it pumps hydrogen peroxide out of its cell. And obviously, you don't want to be swimming around in hydrogen peroxide. And so a lot of other organisms are disrupted. And so those are ones that we call emerging problems, where they can produce toxins. They do cause problems in some places around the world. But here in California, we don't see too many problems from them. And so we keep an eye on them because we want to make sure they're not getting worse. But it's not something that's going to shut down the entire crab industry, for example. And so again, just pointing out that a harmful algal bloom simply means something that we don't like. And so it's something that causes mortality in marine mammals. It's something that is causing problems on the beach. It's something that we don't like for some reason as a human perspective. And so if we go to the next one, all of these can be in the water. And the panel on the right is just showing California, and it's a false color showing chlorophyll. And so the total amount of biomass in the water. And so we can see really easily how much stuff is in the water pretty easily using something like a satellite. You can go down to the beach and say, oh, the water looks brown or green, but it doesn't necessarily tell you what the cell is. And for that, we need to go and look at it under the microscope, and then we can actually identify those individual cells and say, well, that's something maybe we should be worried about, or that's something that we shouldn't be worried about. And so one thing I want to point out is all of these are naturally occurring. And so it's not something that we're going to eliminate this and we're not going to have these ever again, because they're just part of the ocean. But there are things that we do that can make them worse. And so some of these we know respond to nutrient pollution, for example. And so even though they're naturally occurring, there's things that we want to avoid doing to make it worse rather than better. And the other thing I'll just point out, and then we can go on, is that chlorophyll in general, these phytoplankton in general, are good. They're fantastic. It's the base of the food chain. If we didn't have them, we wouldn't have whales, we wouldn't have oxygen, we wouldn't have any of those things. And so the fact that some of them produce these toxins and occasionally cause problems, we often focus on that, but 99% of the time, the phytoplankton are just doing their thing and they're supporting life in the oceans and life on the planet.
Excellent. Thank you so much. And Casey, can you tell us a little bit about what you've observed at the Monterey Bay Aquarium?
All right, who has been to the aquarium? Okay, excellent. So I think you are all familiar then with this site here, our kelp forest exhibit. So I really want to follow up with Dr. Cadella's comments that there are algal blooms that are toxic and there are algal blooms that are potentially harmful, but those aren't necessarily the same thing. And so to his point, anything that we consider harmful might be something that we don't like. It doesn't necessarily have to produce toxins. So at the aquarium, we are directly connected to the ocean itself. We do draw our water right out of the bay, so anything that's in the bay is going to end up right in our exhibit. So from an applied setting, we're actually completely concerned with everything that's going out in the bay. We monitor it very closely because you can see it, and if you go to the next slide, I'm going to show you an example. There you go. So has anyone here ever seen the kelp forest look like that? No? Okay, that's great. That means we're doing our jobs most of the time. But this actually occurred in October of 2016. There was a large algal bloom off our coast. And since we do bring the water in right from the bay, that's what the kelp forest looked like. So every once in a while, we come in the morning and we go, okay, wow, well, that's interesting. In the evenings at the aquarium, we do let raw water, what we call raw water, which is unfiltered seawater, come into the aquarium. So it actually feeds everything that's in the kelp forest. It brings in new life. It actually makes the life of the aquarium much, much better and more productive. During the day, we actually do filter that water so that you can see everything. But in the evenings, if there's an algal bloom out there, we can bring in anything that's in the bay into the exhibit, and that's what it ends up looking like. So in October 2016, there was a particularly dense bloom out there in the bay, and the plankton toads at the Monterey Wharf actually showed a week after this about 9 million cells per liter. Square liter, that's a new thing. Did you know you measured that? No, I didn't think so. So that's a lot. That's a lot. And so what this actually ended up being, we actually took some water samples, and if you go to the next slide, I wanted to show you a photo. MF Fiore, our microbiologist who's actually here tonight, took this photo. And it was a Kashiwa, so it was one of those ones that was mentioned before that doesn't necessarily produce a harmful toxin, but it can do a lot of things to our exhibits themselves in terms of visibility, and it can cause the water out in the bay to look that greenish or reddish color as well. One thing that we do see and worry about with the Kashiwa is that it can produce a surfactant or a soap-like substance, and that's that foamy stuff you see on the beach after an algal bloom. It can affect the oils and bird feathers. So there is potential effect there, even though it's not necessarily a toxin. I mean, there's some argument there on what the toxin is or not. It can potentially cause a harmful effect. So that is something that we do monitor to make sure that that's not reaching the rest of the exhibits where there might be potentially birds. We've never seen an issue with that or with Pseudonychia and Domoic acid toxins at the aquarium. We're very careful about it. But I just want to make the point that not everything is producing Domoic acid. Not every algae out there is toxic. But it can cause issues that maybe we're not a fan of, potentially in our visibility in the aquarium, or the foam on the beaches, or the coloration of the water, and it can also cause other issues like oxygen dead zones and those sorts of things. So that is just one example of something that we see at aquarium on a regular basis and that we want to keep an eye on.
Thank you. So you did mention that some of these plankton can produce a toxin called domoic acid, Pseudonychia being one example. So what is domoic acid? Adam, I was hoping that you could help us kind of explore that.
Sure. So domoic acid, you heard a little bit about kind of the different types of phytoplankton and how in different conditions they can actually release certain toxins. And domoic acid is one that we see in kind of large amounts at different times of the year in California. Now, you see the whole kind of intersection of different species, and one of the things that I kind of both love and hate around domoic acid is that we're so interconnected. We see it impacting things like seals and sea lions. We also see impacts on people around the world if we're not careful. And what we can learn from animals like seals and sea lions can actually help protect people that are getting sick as well. We see a variety of different kind of impacts from domoic acid, and at the Marine Mammal Center, one of my kind of main roles is figuring out how do we tell these stories of what is this issue, how can people get involved. And domoic acid, in a given year, we might rescue 100 to 300 animals that are being impacted by this, having things like seizures out on the beach. my job was to take those stories and tell third graders about them. Now, you just heard some fantastic information about harmful algal blooms. It doesn't really work great to show them those slides, for example, if you're trying to engage someone in 30 seconds, or if you've got someone who might not have that level. So it was actually a chance encounter as I was trying to figure out how do we tell this story of what is domoic acid, how does it impact marine mammals. And I was volunteering, helping to take care of some of the animals up in Sausalito. It was a very late night. I was actually at the center at around 2 in the morning, helping to feed all these baby seals. And I took a break, was talking to a brand new volunteer, and she was mentioning how she had just looked around the center before kind of she had gotten there, was really impressed by some of the different videos that we had, but had said, have you ever thought of using any different types of videos? All the videos we had were these kind of documentary style videos narrated by this British woman, because I love the British accent, and I thought she'd make a great narrator for these videos I made. And I said no, because I don't really have any artistic ability to make anything different. And she kind of giggled a little bit, and she said, well, have you ever tried something like animation? I said, I love animation. I have no idea how to do it, so no. She laughed and said, well, that's interesting, because I work at Pixar. To which I responded, you are now my best friend, and let's talk when it's not 2 o'clock in the morning and see what might be possible. And it turns out that she was also a professor at the California College of the Arts. She taught classes for undergraduate animation students. And she was telling me that they're actually really struggling to find different projects for budding animators, because all of the budding animators just think the jobs are Pixar and Disney. But they lose all these educational animation opportunities, these scientific animation stories. So we created a course at the California College of the Arts where we had around 15 students develop a scientific animation for us. And I am pretty sure they thought I was going to ask for like a rescue, acute feeding. Class started, and I asked for a family-friendly video on domoic acid toxicosis. And they shockingly did it. And I want to show it to you next. This was something that we use with all ages at this point. It's up on YouTube. Anyone is welcome to view it or use it. And take some of this science. It does simplify it, without a doubt, but gives you an idea of how domoic acid is in the food chain and then how it might impact animals like seals and sea lions. Take a look.
Whoa, look at those funny looking seal dudes.
Those are sea lions, Kyle. The ocean is home to a lot of different animals like that. Sea lions are the dogs of the sea. Like cows eat grass, fish eat plankton. Sometimes, plankton produces something called domoic acid. It is toxic in large amounts. When fish eat the toxic plankton, they become poisoned by the domoic acid. Sea lions eat upwards of 100 fish a day.
Whoa, I can't even eat that many pizza rolls.
When sea lions eat a lot of fish poisoned by domoic acid, it causes them to get really sick. The domoic acid will attack the sea lion's heart, weakening the heartbeat. It will also attack the brain. In serious cases, the domoic acid even causes part of a sea lion's brain to shrink. This causes the sea lion to act dizzy and disoriented.
Smile.
No! It's important you call the Marine Mammal Center.
Hello, the Marine Mammal Center.
Yes, we found a sick sea lion on the beach.
Okay, a rescue team is being dispatched. Keep everyone away from the animal.
Kyle, sea lions are wild animals. They can bite.
Huh? The Marine Mammal Center was created to take care of all marine mammal dudes. When an animal is stranded or is in need, always call This way, the dudes from the center can pick up the sea lion and care for it at its excellent facility. And as soon as it feels better, they release it back into the wild, where the sea lions can live happy and healthy lives. Yeah.
Say, don't be a Kyle, which I found to be, was not the intention. So I'll take it.
To learn more, check out their website.
A little bit about what happens though. You saw the simplified version, but now what is it like if an animal gets Domoic acid?
All right, so I actually had not seen that full video before. That was awesome. So most of you are from this area. Have you seen a scene like this on the beaches before? Maybe some, yes. I see some volunteers out there, so you probably have seen this. Domoic acid, like you saw in the video, can impact the brain of marine mammals, which becomes pretty important when you're trying to rescue those animals. So it actually creates disorientation, memory loss. The sea lions are essentially acting like they might be drunk or have really severe memory loss, which when you are then dealing with a 400-pound animal can be a little scary. The sea lions, they'll be head weaving. Sometimes they're just wandering around in circles. Other times you'll see a sea lion in a really weird place, like crossing Highway 1, wandering through cow pasture, just places you wouldn't expect to find a sea lion. And that's because they're suffering from this domoic acid toxicosis. It creates a really difficult situation for our trained rescuers. A lot of times these animals are very large and they're otherwise healthy. They've been eating plenty of fish, which is the problem. So they're healthy, they're strong, and they're confused. So it takes usually a lot of extra bodies, a lot of extra planning. Can be a really difficult situation to rescue them. And they'll sometimes look like this guy. So a lot of extra people out on the beaches trying to rescue these folks. We do have a triage facility here. It's actually just down in Moss Landing. Any of the sea lions we rescue in this area will pass through our Moss Landing facility first, which is important because when these animals are suffering from domoic acid and they look something like this guy, the first thing we do for them is provide a lot of fluids, like liters and liters and liters of fluids. And this is to just try and flush all of that domoic acid out of their system. The faster we can clear their systems of the domoic acid, the better their chances are for survival. So that's the first step, and our researchers and scientists and veterinarians are actually working on different methods for how we deal with this. There's no surefire way to cure domoic acid toxicosis. It depends a lot on whether or not we caught it early enough and how many fish that sea lion has actually eaten that are poisoned. So we start with that and then just continue feeding them fish that are hopefully free of that domoic acid and hope that their condition improves from there.
So with the care down here in Monterey, it's people like you out on the beach that are seeing these animals and giving us a call, that 24-hour hotline to let us know. It's volunteers, people just like you that are helping us rescue those animals, giving them those fluids, getting them up to the main hospital in Sausalito, where we're able to continue that long-term care. It might be just a couple weeks, 2-3 weeks of those fluids, anti-seizure medications before the animal can go back out to the wild, just like what you see in this picture here. So these animals are able to get a second chance as long as they're found in time by people like you out on the beach. And we can not only help those sea lions, but it really helps inform a lot of the work that then happens in the community. So the Marine Mammal Center, along with partners like University of Santa Cruz, were able to identify this toxin in 1998 for the very first time in marine mammals. And we then worked with groups like the Department of Public Health. So when we saw a bunch of sea lions washing up on the beaches suffering from domoic acid, we could get on the phone, we could call the Department of Public Health, and they could ramp up or focus some of their testing. We essentially had a canary in the coal mine because these seals and sea lions act as sentinels for the sea in a way that we can not only give them a second chance, but also protect people at the same time. So I really find this story incredibly powerful to be able to help really think about what are we able to learn about the health of the ocean from some of these animals that spend their time there. They're mammals just like us. They breathe the same air that we do, they eat the same food that we do. So there's a ton of connections and reasons why rescue programs like the one that we have down here and over 600 miles of California coast are so important, and a huge shout out to the community that allows this to happen. We might rescue 700 to 2,000 animals a year because of phone calls from people like you. 1,400 volunteers stretched out over 600 miles of California coastline. So from Mendocino in the north all the way down to San Luis Obispo. So a huge testament to some of the work that's happening in each community to help these animals and help people at the same time.
Thank you so much. So now I kind of want to transition. We've heard about these events that we experience in our oceans, and we hear a lot about our oceans changing due to rising temperatures. So obviously climate change is a huge concern that we're facing right now, and we often hear these projections of how our climate is going to continue warming in the coming decades. And with that, our oceans are going to continue warming as well. Some of our ocean currents may also change, and we've already experienced some of those changes already. So Casey, would you be able to describe what you've observed at the aquarium through your monitoring?
Thank you for holding the microphone for me. Appreciate it. So yes, so think back and put yourself back in 1984, and you're going to open an aquarium to give everyone a window to the Monterey Bay. You're going to put in that aquarium regional animals that are available right off if you were going to go diving, but you want to be able to show them to the world so they don't have to get into 50-degree water. I'm all for that. And then it goes by, 30 years or so, and you realize that the oceans are changing. What do? That's a huge discussion that we have on a regular basis, not in an alarmist fashion, but it's something that's been going on every year for 20 years at the aquarium on what's going on out in the ocean, what's the human impact going on, what's the climate change impact, what are the waters doing, what happens when a blob comes, which Dr. Kudela is going to speak to a little bit later. So we started looking into this last year actually and looked back into our data. We do have temperature sensors, oxygen sensors, pH sensors, among other things on our intake pipes so that we can see the water that's coming right into the aquarium before it even hits our exhibits, which gives us a great window back out into the bay itself. All that data is also publicly available, and they're going to give you a good list of places to access our data and other people's data as well at the end of this. But this graph specifically looks at our seawater temperatures coming into the aquarium on our intake pipes from 2017 to 2019. So I'm going to break this down a little bit for you because there are a lot of graphs going on and there's a simpler one following. But what I want you to see right now is that yellow line. That's kind of a jagging line up there. The line graph part of it is actually the mean or the average monthly temperature for each one of those months from 2018 to 2019. Okay? And that gray line that you see below it is actually the average temperature from 2016. So if you just look at those two lines and ignore the bar graphs in between there, you can actually see that that average from the last year, 2018 to 2019, is actually higher. And that is a significant difference when we did the stats from 2016 on most of those. Now, I don't want to say that that indicates a long-term trend. Keep in mind this is actually just a difference between 2 or 3 years. So there have been instances of warming water like the Blob, and then it cools back down. So please don't take away from this that I'm saying all the water is warming and it's going to stay this way for forever. This is just a snapshot in time, but it's an important snapshot to take a look at. Okay. Now, if you transition over to the orange bars and the blue bars, those are actually the monthly lows and the monthly high temperature. So we record data every 4 seconds coming into the aquarium. So this is, I just pulled the lowest temperature recorded that month and the highest temperature recorded that month. And if you can just take a look over on the right side in 2019 at all those orange bars compared to over on the left side in 2016 at all the orange bars, they're all pretty much higher in 2019. So basically what we've been seeing in 2018, 2019 is warmer temperature than we had seen the last 2 years, which is interesting and impactful for what's going on in the bay itself and a discussion on climate change in general, but also has an impact on what we're doing in the aquarium itself. If you want to switch to the next one, there's a simplified version for you. I like to show the complicated version and the simple one. So again, the top line there is the average monthly temperature from January to September in 2019. And that's the orange line. And then in 2016, the average monthly temperature for those same months in 2016. So you can see that there is definitely a difference between 2019 and 2016, which has an impact on a lot of things, including the algal blooms themselves. But this is something that we keep an eye on, and you guys are able to keep an eye on as well through a lot of online options. And we can just monitor those seawater temperatures and see what those trends continue to be throughout the years and the cycles, and then eventually be able to relate them to long-term trends in climate change.
Thank you. So, Dr. Crudella, if you could describe to us what are we seeing in the phytoplankton abundance with these warmer waters, and if you could describe the blob event that Casey was referring to and just kind of tell us what that event was.
Sure. So how many of you have heard of the blob? A good number of you. All right. So that was a term that was provided by a Stanford graduate student that also came up with the atmospheric phenomenon that caused it, which was named the ridiculously resilient ridge. And it's essentially the atmosphere shifted in the Pacific Northwest, and it allowed the surface ocean to get really, really warm. And so it's a little bit like El Nino, which we all experience. El Ninos come 4, 7 years, 9 years sometimes, and they last for about 9 months. And so we'll have warmer than usual weather. Oftentimes it's rainier around here. What was unusual about the blob, it's something that we now call in the science community a marine heat wave. And so just like a heat wave on land, it means that it's unusually warm for some extended period of time. And so that blob, to put it in perspective, 97, 98 was a massive El Nino event here in California, and it resulted in the coastal waters, say at the Monterey Bay Aquarium, increasing by about 3.5 degrees Celsius. But it only lasted a few months, and yet it causes all kinds of problems in the ecosystem. The blob lasted for about 2 years, and it ended raising the temperature in Monterey Bay by 5 degrees Celsius. And so a few months versus a few years, and actually warmer water when there was the blob. What was a little bit concerning is that after the blob went away, it's still kind of sitting up there in the Pacific Northwest, and as you just saw from Casey's data, the temperature has never really recovered. And so we actually have a shift to warmer temperatures today than we did before 2014, 2015. And we're trying to figure out, is that just going to go away? Is that going to be the permanent way things stay from now on? And we don't really know. We're looking at those data. And so that warm water, you know, we can all think like, I personally, if I were going on vacation, I'd go to Hawaii because I like Hawaii. It's beautiful and it's warm. And so I'm not going to go to Russia and freeze. And the phytoplankton are the same way. They like a certain temperature range. And so Pseudonychia like sort of intermediate temperatures. And so they generally show up in the spring. In the summer, they typically tend to go away because it's a little bit too warm. And then they come back in the fall. And so when we had that big warm blob in 2014 and 2015, if you think of it sort of like Goldilocks, it was the perfect temperature along much of the west coast. And so Pseudonychia took over. It forced the other phytoplankton out because it was doing better, and it just hung around. And then what happens is, as the Pseudonychia is growing, it's not producing very much toxin. As it runs out of nutrients, as it becomes unhealthy, it starts to produce more toxin. And then we might get a storm come through, they get a little bit more nutrients, it goes back to growing, and then it gets unhealthy, it produces more toxin. And so we had this really prolonged period when the Pseudonychia was producing all this toxin. And that ended up resulting in the shutdown of the Dungeness crab. It caused all kinds of problems with marine mammals. There were warnings about not eating shellfish. And it's simply because the conditions were just perfect for Pseudonychia to grow for that long period of time. And so on this graph, the one at the very far left shows 2015, and that's basically where that green sort of blobby area is where we saw Pseudonychia producing lots of toxin. And this has been color-coded. What we've seen is that Pseudonychia, again, it likes a certain temperature, and so we can look at these models and say, well, where would you expect to see most of the toxin being produced? And so we were able to color-code it, and so green, lots of toxin, yellow, still some toxin, but less of it, red, it's too warm. And so what we saw is actually in Southern California and Baja, normally they would typically have toxin down there, and it was actually too hot down there in 2015 for Pseudonychia to produce toxin. But you'll notice that it went all the way up past Vancouver Island, and it wrapped all the way around through Alaska. And that was the first year Alaska has ever seen domoic acid in their waters. And so they had the cells, but they never saw the toxin. And so we can take that and we can say, well, what's it going to look like in the future, which is oftentimes the question that people want to know about. And so we've combined this with the climate models, and you're looking at 2015, 2030, so roughly 10 years from now, 2050, and then 2080 towards the end of the century. And what you see is the green is going further and further north, and the red is shifting up as well. And so one of our predictions, if nothing else changes, and there's lots of other things that could change, is that domoic acid might actually not be a problem in California anymore, which might sound like a good thing, except it's going to be a huge problem in Alaska. And so it's just going to keep shifting north. The other thing that we're really concerned about is that as that red water moves up, it's going to bring algae with it that likes that warm temperature. And so we might have something, instead of domoic acid, we might have another toxic algae that we've never seen before here in California. And so that's really the long-term concern, is that we have a pretty good understanding of why these organisms are where they are, what conditions drive them to produce toxins, and we're just starting to get a handle on, well, what does that mean for the future? And so if we have a warmer ocean, what's that going to look like? What we think it's going to look like is we're going to have more and more problems starting in our area, extending up into Northern California, and then just continuing all the way up into Alaska. And so again, you know, maybe if you're a fisherman in California, that might be good news. You have less toxin down here, but it's not good overall because we're just moving the problem around.
So interesting. And I'm just wondering, with all these massive changes in our oceans, you know, we're experiencing changes in temperature and changes in the phytoplankton community. What other shifts and changes are we seeing? I was hoping, Julia, if you could answer this one, and Lisa, if you have anything to add as well.
Sure. So the first change that's probably the easiest for us to see here, we would have seen in 2015, when probably a lot of folks saw a lot of the really young sea lions washing up on the beaches. This was a problem up and down the California coast. That blob that Dr. Cadella was discussing, it happened right around the time a lot of these younger sea lions were leaving their moms and looking for food for the first time on their own. So all of the young sea lions we saw showing up on our beaches were emaciated, severely underweight. A lot of them didn't make it just because they couldn't find that food, and it was because the food source had moved from an area where sea lions for thousands of years have known where to find it. This year, if you've been watching the news, we're seeing what NOAA's just announced as an unusual mortality event for gray whales. And it's the same issue. Most of these gray whales that we've been able to find on the beaches, stranded and passed away on the beaches, are malnourished. So they're not able to find the food that they would normally need and normally can find very successfully up in Alaska. And a lot of that is due just to the amount of ice that's melting and the amount of ice that's no longer there. Like the good algae that we normally need and see in the oceans to feed all of the benthic, the bottom living organisms that the gray whales feed on. Those organisms just aren't there anymore because the ice has shifted and waters have moved it around. And if they can't find that food during the summer months when they're feeding, they aren't able to make that really long journey back to Mexico towards their breeding grounds. So we're actually seeing a difference in the gray whale populations here and in Mexico because of the amount of ice that's just not up in Alaska anymore. So quite a few changes that we see all the way up the food chain.
Yeah, I would say that we've talked a lot about the plankton and the warming of the ocean, and how many people have learned about ocean acidification? I told Emily I'd bring this up because I feel like as we, of course, humans, we're so productive and consume a lot, we put a lot into the atmosphere, and the oceans and the land are inextricably connected. We cannot think of those two as being separate. And as we continue to put more and more carbon dioxide into the ocean, we're changing the chemistry of that ocean. It's becoming more acidic. And in that, it's affecting pretty much plankton is one of the biggest things that is affected by that. There was a recent study that came out that it was showing that organisms that use calcium carbonate to build their shell, something like an oyster larva, or something like Globigerina, which is a type of plankton, They've shown, they went back and looked at records of these plankton and their shells. They went through all the samples several years ago, and that had been collected in traditional sampling in the ocean and preserved. And they've found that the shells are thinner now today. And we have so much to be thankful because plankton could produce more than 50% of the oxygen that we breathe. As the oceans are acidifying and the conditions are changing in conjunction with the warming, we can see really huge impacts globally to the plankton populations. So I wanted to bring that up as just a precursor to some of the other things that we're talking about.
Yeah, it's definitely an important topic to bring up. Thank you. All right, so what exactly are we doing or can we do to monitor and research these harmful algal bloom events and domoic acid production? Lisa, can you describe what the Plankton Monitoring Network is? I think multiple people can speak to this.
Yeah, actually, yeah, we can. Monitoring research is extremely important. Here in the Monterey Bay National Marine Sanctuary, we oftentimes are working with collaborators to see what conditions are so we can come up with an assessment of the health of the sanctuary. And one of the key components here, Rafe and his lab are monitoring, seems like 24/7, very vigorously have been for how many years, Rafe? 20 years. They've been monitoring and doing research in the sanctuary and beyond all around to look at these populations. So if you think of over time and space, looking long term, you can get a picture of what's going on with the phytoplankton populations. People often ask, well, what can we do? We here in the sanctuary initiated a program where, with partners, to look at both phyto and zooplankton populations. And you, as a citizen scientist or a community scientist, can get out there and can collect. We currently have 7 sites along the sanctuary's coast and up north. And I just had one of our students from Carrillo College contact me today and said she was going to start her own plankton monitoring up at Humboldt off the coast to look at plankton on a regular basis, which is great. I often go, I was just in Barcelona 2 days ago, and I'm on Barcelona time, and I was down at the ocean, and I was just sitting there thinking, I wish I have my plankton net with me and my portable microscope. And I decided this would be a really cool thing in retirement to do, to go to as many places as I can and monitor. We actually train people in looking at plankton under the microscope, and it's an incredible experience. How many people here have gotten the plankton itch? You know, this is the charismatic microfauna that Emily mentioned, that when you look at plankton, because it changes, it's very seasonal over space and time, it's the coolest thing because you see new things. We oftentimes get people contacting us in our little group listserv saying, what is this? You know, can you help me identify this? And with the help of experts like Rafe and his team and the State Biotoxin Monitoring Program and the National NOAA Phytoplankton Monitoring Network, we're able to have a conversation around plankton. And I think we're kind of hoping we're helping Rafe, because we have people out there weekly. They're looking at this information. They're putting it into a publicly accessible database. And we can look at trends so that, 30, 40 years from now, we can look back at what species are here. And along with that, these volunteers are taking information like water temperature, salinity. We're getting to the point where we can take pH to help monitor for ocean acidification. And then other physical oceanographic things, as well as just observations. So just observing what organisms are there on that particular day. So if they see a sea lion, if they see a particular bird, it's been interesting. So we've been at this now for about 1.5 years with our network, and it really is a combination of many partners. If anyone here is interested in getting trained, Cabrillo College has a course that they offer every semester on Fridays, and you get trained up on microscopes, looking under microscopes, looking at plankton, and going out and collecting on a weekly basis. And this best part about this is it's a no fee, no credit course. So you can, anyone can do it. Do we have any plankton monitors here that are in the course? Talk to them and find out about it. So monitoring is important, but also I think I'm very thankful to plankton because we wouldn't have this incredible ecosystem here. It really is the plankton that sets the tone and reverberates up the food web for feeding all these animals. And so by monitoring it, we can look at what's going on and see if there are, incredible impacts over time. And I think in that regard, much of this is very much about people always ask me, well, what can I do? What can I do? And I think it starts with the usuals because climate change is such a huge issue for us. It's all of us lessening our carbon footprint, and we can do that in a number of ways. One other parameter I should mention that we take, that this is Rafe's lab developed this. There's one here and also up at the Exploratorium, but it's different colors of the ocean. So imagine, I see this as an art project. They took, was it Sherwin-Williams? Yeah, Sherwin-Williams colors, and they have all these colors that you can look at, and when you're out there monitoring, you're going to be saying, what color is the water today? And then if you put that on a timeline and try to quantify it at different spots in the ocean, and plankton is very patchy, so it can vary on the meter level to huge, vast areas. Very important, one of the data points that we try to take with our monitoring. But from the carbon footprint thing, usual things, we can all, lessen our impact on how much carbon dioxide we're using or we're creating. And also, plankton is small. Phytoplankton in particular, on average, is 100 microns. Or less. Can be a little bit bigger, 500 microns. This means that when we're out there sampling, we're picking up microplastics. So here's another thing we can do as a community. We can get rid of that habit of single-use plastics. Don't use plastics. Use reusable bags. And I'm pretty sure that just as a whole community and society, it's going to be on that individual basis that we can conquer these large, huge problems like plastics in the ocean, climate change, and other things. And it has to happen on an individual basis. And it's not that easy to do. So that's what I encourage people, just one step at a time, to take those different steps.
Thank you so much. Does anyone have anything else to add about monitoring, research, or community involvement before we go to audience questions?
Yeah, so as I mentioned before, there is a wide variety of data from the aquariums, incoming seawater, as well as other monitors out available on the internet in many places. We at the aquarium do monitor and have almost since we opened pH, so we do have a large subset of data for pH changes in the Monterey Bay since the 1980s. We do have oxygen levels in there as well. We're actually about to put a fluorometer on the intakes as well, and that data will be available publicly, and that will give you chlorophyll readings to help that correlate to what's going on in the bay. And we haven't got quite, we're still working on something related to the color in the aquarium, but our lab manager is taking regular photos of our kelp forex exhibit, particularly during blooms, and trying to monitor that color in the same way that Lisa mentioned, so that we can actually have kind of a horizontal view into what's going on in the bay, as well as correlating to that vertical view, because a lot of times you're looking at the surface of the water, and what's really unique in the kelp forest exhibit is that we can look 30 feet down at what's going on and look at it from the side, which you can't always do without getting under the ocean surface. So more on that to come, but that's something that will be available eventually as well.
Yeah, I was just going to follow up on Lisa's comment about what you can do, and I think you all know this and you've heard it before, but vote. That's going to change things at the national and international level, and vote with your dollars. Support the Marine Mammal Center, support the Monterey Bay Aquarium. You know, if you value those resources, then show your support for it, and that's how individuals together can have a big impact on where things go.
So something that I'll add, just there are lots of actions that we can take at individual levels and coming together as communities, whether that's schools, whether that's businesses, whether that's homes, however you define the communities that you're a part of. But something that I found really interesting is right now the vast majority of people in the US believe climate change is happening, is real, and is going to have impacts. But actually 65% of people in the US don't talk about climate change. There's a spiral of silence around it. I see climate change probably 35 times a day in news and conversations and things like that. But actually only 1 in 5 people in the US hear about climate change more than once a month. So that creates actually a spiral of silence around the issue of climate change. If you don't hear people talking about it, you don't think other people care. And then it perpetuates. So in addition to doing these behaviors, in addition to voting, talk to people about it. Find out what they value. Because they might value different elements. Maybe it's things like Dungeness crab that they love eating and the impacts that it could have on it, and ways that we can protect Dungeness crab both for the oceans and for people. Maybe it's around things like sea level rise and how that's impacting the beaches that elephant seals depend on, but also all of the homes and communities that we depend on. So find what makes that value for the people that you know and have conversations about it. Have those solutions-oriented conversations. We know that actually fear is not the best motivator for change, despite everything we try in the media. So talk about it and give people that hope that they need. Give people that sense of a community of people that are out there trying to tackle this issue, and that'll go a really long way. The power of your voice, in addition to your vote and your dollars, has just as much impact.
Well, I just wanted to thank everyone here for all the wonderful community involvement coming to events like this, but also all of our wonderful volunteers and the public who call in all of the animals to our hotline and just let us know what's going on out there on the beaches. We really rely on the community involvement to do the work that we do, and I'm sure that's true for all of our organizations here in the Bay. So thank you guys for being involved.
Great. All really great comments. Thank you so much. A few of our speakers mentioned some important resources, so if you're interested in learning more or keeping a closer eye on some of the conditions in our ocean, checking the phytoplankton community, checking the domoic acid levels, you can do that. We have some resources listed here. If you want to take a photo of that on your phone, we also have a printout at our table in the back. So if you'd like to pick one up on your way out, you can do that as well. And I think with that, we can open it up to questions from the audience, if anyone has any questions.
Thank you. You're talking about effect of demonic acid. I understand that a lot of contribution of causes are from nitrogen, from phosphates from the farmland and sewage outlet. And this is beyond, of course, beyond our ability to deal with it. It's our legislators, and I don't think it's being dealt with. But as far as water warming, you focused in on about 3 years, as I recall seeing. And I've been living around the ocean most of my life, and for about the last 50 years, I've seen it in this area go from a low of 43 to what it is now, about 57. That's dramatic. I've seen Santa Monica Bay at 78 a few years ago, and it turned green. But look, I don't know what else to say. I'm making statements, but I think that this audience, people involved, should get involved with the farmland runoff. We're losing a lot of farmland through housing. Everything's housing. And I talked to, the old way of doing it was to turn over the land. We need more farmland because a lot of the farmland is limited. They're using farmland for high intensive growing, which we need, but it's that intensity is coming from phosphates and nitrogen. Thank you.
Thank you for sharing your experience. Do we have anyone able to speak on agricultural runoff impacts of that?
At the Monterey Bay National Marine Sanctuary, we have a water quality program where our staff are working with partners throughout Monterey Bay to work with farmers and some of the agricultural community partners to help them with best practices, if you will, for nutrient loads and things like that. And that's one area where I think there is good impact here in this area, that they're working with best practices to, sort of decrease nutrient loads going into the ocean, to the sanctuary. And we often are looking upstream and working upstream with those farmers to see what's coming down into the sanctuary. So every year we have something called First Flush and Snapshot Day, those first rains of the year. There is an army of organizations and partners that go out and take different measurements to see what the condition is going into the ocean. I don't know if that helps or alleviates any concerns, but there's good research going on with that.
So you bring up a good point, and you kind of hit the nail on the head on the age-old conundrum of sustainability, right? We have to eat, but we also need to protect the environment. We have to use the environment to eat. So especially here in California, yeah, it's an interesting conversation because we are the breadbasket of America. There's a lot of agriculture going on right in our backyards, and that is a huge sustainability discussion over the years. I don't think there's one silver bullet for it, and I think you touched on that in your comments there. I would encourage you guys, if you have time, to go and do some of the tours of some of the farms that are open to that. We have seen huge increases in farmers taking their own initiative, mainly because of community outreach and community where their dollars are being spent, and your guys' voices. There's a lot of work being done in terms of recycling nitrogen, recycling the water that's being put into the water and trying to harvest some of that fertilizer back instead of allowing it to go into the groundwater. And there's a huge network of farms that are doing that, but it's difficult to talk about. It's difficult for them to bring that up because it is a touchy subject, particularly around here. So I do encourage, if you're interested in some of those things, a Google search will show you some of those. They're not silver bullets. I'm not saying all farms are doing that, but there are some really unique farms in the area that are working very hard on their own initiative that don't make the news, that you guys should go check out. It's an interesting and fascinating issue to look at.
I was going to comment on that. I know there's a lot of other questions, but one success story and just something to point out is we've done some nutrient tracing, and farms are definitely part of it, but another big part are leaky septic systems. And so if you're not maintaining your septic system, that goes straight into the ocean, and we can see that signature. But the success story is that because of the drought, the city of Watsonville actually started harvesting their sewage water and selling it back to farmers because it was valuable. It has nutrients in it already, and it's a water source. And we saw an immediate decrease in the amount of nutrients and the amount of blooms that were occurring around the Watsonville discharge pipe. And so simple things like that, where you can actually turn it into an economic incentive and say, instead of just pumping the water into the ocean, find another use for it. And so those are things that can work, and it does reduce the problem.
Thought this was my night off, but thanks for bringing up the agricultural issue, as our oceans and land-based food systems are so intricately intertwined. And I'm a researcher and work in organic food, and we are working very closely on leaching from farms. And one solution and something we can all do is to support our organic farmers. Organic farms leach, at least 50% less nitrogen, and also don't use synthetic forms of nitrogen, so they don't leave persistent toxins. Not to say that, manure or other biological fertilizers can't leach into waterways, but organic farmers also have to follow a really strict set of protocols that entail not having soil uncovered and things like that also help reduce leaching. So I welcome more conversation, and if you want to find me afterwards, I would love to. And we are also looking to partner with folks working on these issues in ocean-based food systems. So thanks.
Thank you. Any other questions? Yeah.
So I think everyone here is very receptive to everything you've been telling us about all these issues. But I'm curious about, what are your frustrations in terms of communicating your science or message to the public, and what do you think are solutions that you could undertake to further your message outside of this group of people who came here to see this talk tonight?
Just a side note, if you know anyone interested in this topic who wasn't able to make it, we are recording this session, and it will be on our website, so we can share that afterwards. Anyone want to speak to that?
So I'll start. I love the question, and it drove me to join a collaborative, something called the National Network for Ocean and Climate Change Interpretation, or NOCI for short. And basically what we were able to identify is that we weren't communicating about climate change particularly effectively. We had some really good science, but we weren't necessarily using the right language to talk about it. So what they wound up doing is they brought climate scientists together with social psychologists, and we scientifically tested the language use around climate change. And what was really fascinating about that is that we tested a bunch of things that we had already been doing. So for example, everyone has heard the metaphor, the greenhouse gas effect, when it comes to climate change. We tested it. Spoiler alert, doesn't work very well. A lot of people don't understand how greenhouses work. Different issue for a different day. But if you're using that metaphor to talk about a problem, we're not necessarily going to move the needle. So they tested a bunch of different things, both in terms of metaphors. So something that I use, and we've actually seen national discourse shift with this language, is actually the heat trapping blanket metaphor instead. So as we burn fossil fuels like coal, oil, natural gas, it releases carbon dioxide into the air, acts like a heat trapping blanket. It warms the air, the land, and the sea. Now, there's a lot more in climate change, but I basically explained the basic concept of climate change in 2 sentences, and in a way that a second grader can understand it and an adult can understand it. Identifying values, talking about things around issues that everyone agrees on. The idea that we should protect and preserve people, places, and environments, or that we should take steps now to prevent future harm to those issues, has shown people being more likely to engage in the conversations, more likely to take action. So I think thinking about how we frame what we're talking about around climate change can bring a lot more people in, as opposed to leading with doom and gloom, which we've also tested and unfortunately doesn't work particularly well. It's incredibly paralyzing, is the problem with doom and gloom. Hope, on the other hand, actually gives people reason to act. If you fate things, there's no reason to actually do something about it. So shifting the narrative a little bit and talking about solutions that are local, talking about solutions that build community and have co-benefits to them makes a big difference, whether that's community gardens, so that people are planting more, but also getting their food closer, cutting down on the transportation footprint. Whether it's encouraging your communities to electrify public transportation so that more people have these opportunities. Community choice aggregations for energy. I know that Monterey and Santa Cruz County have options where if you can't put a solar panel on your roof for whatever reason, you can work with your energy provider to get renewable energy sent in through the power lines. So things that can make the sustainable options the default options can go a really long way to moving the needle on this issue.
I'll just follow up what Adam said too about some of the different topics that are involved in conservation. Listening can be a really valuable tool as well. Conservation is something that we're all involved in, whether we're talking about it that way or not. I'll say working on the Gulf Coast in Texas or growing up in Iowa, some of the topics that we were usually talking about were very different than the topics that I'm talking about today. But everyone's involved in conservation. Clean water, whether you're in Flint, Michigan, is a hot topic right now. Getting the trash out of the bayous in Louisiana was a really big issue for all of us. So I think just also listening to the conservation issues that other people are facing can be a really valuable way of starting a conversation as well.
Thank you.
To speak to the first part of your question directly, what are some of the frustrations that might show up in communicating these topics? One of the things I mentioned talking about the farms was just the fear or unwillingness of some of these farmers to discuss some of the options they're making, and that's not just limited to farmers. I think that's a broad issue across the board for not only individuals but corporations who might be wanting to take steps towards sustainability. And what I'm talking about is there's a tendency in our culture to point the finger at everything that's being done bad and who's doing it right now. So who's polluting the water? That company is doing X, Y, Z, and that's going right into the waterways. And not saying that people who are actively polluting shouldn't be called on that, but however, it makes it difficult for them to communicate steps they are trying to take to make it better. And there is a lot going on, particularly in some of the corporations and from private citizens and from farmers who are taking steps to improve sustainability. And it's difficult to talk about in our society because it automatically triggers a small subset to go, well, okay, you're making improvements, that means you must be doing something wrong, and focus on that one wrong thing. And so I think it's really helpful to be able to engage in partnerships like what you guys are doing with our organizations and actually be open and listening to what people are doing to move forward, and instead of focusing on what somebody's doing wrong now or has been doing in the past, to partner with them and celebrate successes and steps forward that they're taking to make even something a little bit more sustainable in our society. And that encourages those organizations to do even more and take even more steps and be able to put it out in the open. And so I think that's really important to focus on successes and moving forward versus what's happening now or what has happened in the past.
Great. Other questions? All right. All the way in the back, I see you first.
So I have some friends that work pretty closely with condor restoration, and it's been pretty definitively linked that that is a 100% human-caused problem with lead poisoning, stuff like that. And I'm wondering if we have the same data with domoic toxicity and whether or not the scientific process has actually validated the recovery efforts that we do for animals, or if there is some natural die-offs that should be expected from that kind of poisoning, and how do we even gauge that ratio that we should be focusing on for conservation?
So to speak to your point, domoic acid is natural. It's been around ever since that diatom evolved, and so probably way longer than humans. It's difficult to know how much is being directly attributable to humans unless you have a long data set. And we do have a quite long data set. And so, for example, the big bloom in 2015, that was the largest bloom and the most toxic bloom that we've ever seen. And so that stands out as something that, well, something was different. And the something that was different was the climate changed. And so to the extent that you can pin that on humans, yes, we can attribute that to it. But we can go back in time, and we know domoic acid, you know, you probably know the story of Alfred Hitchcock and the birds, is that he probably saw a domoic acid event. And so it's not like it's never happened before. It's been happening probably for thousands or millions of years. What fraction of that is being driven by humans is a tough thing to separate out. And that's an ongoing argument in the scientific community. But we do know that these blooms increase with increasing temperature. These blooms increase in toxicity with some forms of nitrogen that predominantly come from humans. And so we can say definitively that the blooms are worse than they were before humans started interacting with the coastal ocean. Does that mean that we cause all of them? Absolutely not. It's a naturally occurring toxin.
On the front around the conservation of marine animals, things like that, it will come as no surprise that California sea lions are not endangered or threatened to probably anyone in this room. I think it does go beyond just rescuing one sick or hurt animal that's suffering from an issue, though, to really make conservation. And that's something I'm really proud that the Marine Mammal Center is doing, that it's really not focusing just on one individual. It's what we can learn from that big data set. 24,000 animals that have been responded to and rescued over our 45-year history. And what we've been able to learn about domoic acid in particular can not only help inform human health, but we discovered it in California sea lions in 1998. But sea lions actually aren't the only ones impacted. So we treated sea otters for the very first time with domoic acid toxicosis. It's a major mortality threat for the threatened sea otter. We see it with the threatened Guadalupe fur seals as well that have been coming along our coast. You heard a little bit about the work up in Alaska and the fact that we started to see whales being impacted by domoic acid. So that's one reason why helping some of these animals can go beyond just helping that individual and help actually inform greater ocean conservation.
Mary, you have a question over here?
So I'd like to go back to the chart, that, if we could, of the water temperatures where you had the bar chart and the line chart as well, because I recently heard that in another presentation, yeah, the one just before that, yeah, that one, great. So what I heard was that the spikes that you see when you look at history, you know, long-term trends, there are always there. But what has really been critical more recently is the blue bars, that the water doesn't cool down at night, and that kind of feedback loop is probably more critical. And I just wondered if you agree with that or have any more observations on that.
I do agree that is something. We didn't point specifically out the blue bars there, but yes, that is a good point. One of the things that we are seeing is not only just one high temperature throughout the month, and that's an important note again, looking at this graph, we're talking about the highest temperature on those bars that we saw in a month. So what is interesting is exactly what you're pointing out. If you look at that whole right side of the graph in 2018, 2019, compared to the same months over on the left, they are higher. So no, it doesn't look like even in the lower temperature ranges or the cooling down periods, maybe in the evenings, that it's hitting the lower temperatures that we've seen in the past. And that's even true for some of our upwelling events that we see when we can monitor the temperatures when upwelling comes in and hits our intake pipes as well. And even those temperatures are a little warmer than we've seen in the past. And those upwelling is coming from deeper water down in the canyon. That is normally older water, so we don't see that as much we don't see the temperature changes as much there, but as it mixes with that surface water, we do see some changes in those temperatures as well. So, yeah, we're seeing that.
Is there any work being done regarding legislation or regarding using plants on the land, either upland plants or wetland plants, to harvest those minerals that are being taken out to the sea, which are causing the problems? And then we can utilize those plants potentially also again for fertilizer or whatever else, you know, and just detoxify whatever's running off in the ocean more, and using that to make more oxygen too.
Thank you for your question. I would actually like to start by saying one thing that Save Our Shores has been exploring is the concept of restorative aquaculture. So utilizing aquaculture processes in a way that work in tune with the natural ecosystems. And we actually had a speaker series last year that addressed this topic at Moss Landing Marine Labs. And so we looked at both in the ocean restorative aquaculture and land-based. And there are ideas in the works for systems that would capture wastewater runoff from agricultural systems, specifically in the Elkhorn Slough, and then run them through series of basically mini kelp forests growing in large tanks that would filter that water. So using kelp and mussels, other ocean like filter feeders to kind of clarify the water, purify the water a little bit, and get rid of some of the excess nutrients from agricultural systems. Does anyone else want to add to that? Other questions?
Hi, I'm going to put my old friend Lisa right on the spot here and trust that she will forgive me. The last time we worked together was on a innovative program. It may have been your idea, Lisa. I don't even know that. It was called The Fisherman in the Classroom. I'm not a fisherman. I run a couple of 50-foot research boats, and I got dragged into it and got excited about it. We had presentations that we did for the kids from grade school, lower mid-level grade school, all the way up into high school. And we would try to be efficient about that and put 2, 3, 4 classes together in a row. I would describe that response to that as consistently, avidly excited. The kids were usually waving their hands and yelling out questions while the bell was ringing and the next class was thundering in. It was a really exciting mechanism for, in my case, just conveying the kinds of work that I've been lucky enough to do on the water for my career. But as a mechanism for delivering any kind of an educational mechanism, I thought it proved real huge potential. And it suddenly disappeared. It was no longer funded. I never understood why, but maybe anybody in the room might have thoughts about that, but maybe Lisa, you could explain what happened to that program or why it died, or if you consider anything like that in the future. Thanks.
Forgive me.
How you wouldn't have fish if you didn't have plankton. So the program that Jim is referring to was, there were 2 programs. One was called Voices of the Bay. And I just, a little background on it because it's an interesting thing. It really adds to the reason why all these environmental issues that we talk about with other humans, not the animals, other animals, is really ultimately comes down to socioeconomic. And I remember in the beginning we brought together several parties and stakeholders in this process. We brought together fishermen, we brought together fish biologists, economists, and we were developing a program to educate. One was a curriculum, and part of that curriculum was something called Fishermen in the Classroom. And in the end, we developed 3 modules. One module was simply about tragedy of the commons, where students could look at fishing and how many boats they needed to buy and how what kind of fish they were fishing and the sort of trade-offs with boats and using gas and the how much it costs to do it and why that mattered. And they'd see how it was possible to fish an area and to sustainably fish an area as well. Second module was about how your seafood gets from the fish being fished in the ocean to your supermarket, to say Safeway. What is the chain that food goes through economically? So why does squid get landed at 8 cents a pound and then it ends up being close to $10 to $15, and I'm probably off on these numbers, a pound when it gets to your plate in a restaurant or for seafood? So that chain, they would actually work through all the fish that were fished here in Monterey Bay and see. And, you know, we'd ask them, and they'd say, well, what should we do? And they were like, cut out the middleman. And that really makes sense. You're seeing now people selling fish directly from their boats, or you're seeing them sell them at farmers markets. The final module was the oral history one, the fishing stories, the fish tales. And that's what Jim did. He did an incredible job because he bridged the science and the fishing. And he went out and he talked to the public and the community, young kids and older kids, right, about fishing. Not really getting to answer your question. But we actually implemented Fishermen in the Classroom this past year with the amount of money that we had. And then also up at the Greater Farallones National Marine Sanctuary, they're implementing pretty rigorously that program. So that's the good news. But I guess the point of all of that is that in terms of someone asked the framing of questions, and oftentimes when we're trying to talk about these environmental issues, it comes down to a socioeconomic perspective that when you're talking with other people, depending on who your audience is and the relevance of it to people. I don't know how that we can tie that to Domoic acid, but the Dungeness crab populations are in pretty dire straits right now.
Okay, I think we have time for one more question, and then we'll do closing remarks.
When I'm camping and I see a lake with a lot of green, it looks like green algae, is it safe to drink it if I filter it with a ceramic filter?
Generally, yes, as long as your filter is operating properly. You could even use something as simple as a Brita filter that has activated charcoal. That'll take most of the toxins out. You're taking a risk, you know, that you are removing toxins, and so I'd still think twice about it and probably try to find water that wasn't green in the first place. But all of those filters are designed for exactly that they will remove things like cysts, but they also remove any of those filters that have an active component to it will remove all of those toxins as well. Swimming, generally, all of these algae that we're talking about being toxic for a human, you would not get exposed to enough simply through recreational contact. It has to be basically magnified in the food chain. The exception to that is if you are small, like you're a child, or if you have a dog. Those really green, scummy lakes can be toxic enough, and it's happened several times in the Bay Area, that a dog will go into the lake, lap up some water, and get very, very sick or even die within a few hours. And it's simply body mass. That, you know, a little bit of water to a dog is a fairly large dose of toxin, and that same water to you, you might not even notice it.
Thank you all for your great questions. We're about to wrap up, so I just wanted to say if you're interested in these types of events, we will be having 5 more speaker series this year. You can visit saveourshores.org/events calendar to see all of our upcoming events. We have cleanups, tabling events, speaker series, you name it. So if you're interested, check it out. You can also sign up for our emails on the back table as you head out, and we'll send you emails when we do have events like this, so that you can RSVP and put it in your calendar. And then with that, I want to say a huge thank you to the Dream Inn once again, and a really big thank you to our speakers. Thank you all.